I want to tell you about a farmhouse in Holmes County, Ohio, that has been generating its own electricity since 1987. Not solar panels, not a wind turbine, not a diesel generator behind the barn that burns fuel someone had to purchase and haul in. The system that powers this farmhouse sits underneath it, in the ground, underground. It has been running continuously for 38 years, with one maintenance visit every decade, and an original materials cost that would not cover 2 months of the average American electric bill. I found out about it the same way I find out about most things that change how I think. Someone mentioned it once, casually, the way people mention things they assume everyone already knows. A man at a farm auction in Millersburg told me his neighbor had not paid an electric bill since Reagan was in office. I laughed because I thought he was exaggerating. He was not exaggerating. I drove to that farm 3 weeks later. The family had been on that land for 4 generations. The current owner, a quiet man in his late 60s named Aaron, walked me through the operation the way someone walks you through something so familiar to them that they have almost forgotten it is unusual. The woodworking shop running, the dairy cooling system running, the lights in the barn and the house running. All of it powered by something Aaron's father had built with his own hands from materials sourced within 5 miles of the property. When I finally asked him to show me the source of all of it, he walked me to a spot in the pasture behind the barn and pointed at the ground. Right there, he said. I looked at a patch of grass that looked identical to every other patch of grass in that pasture. There was nothing to see. That was the point. What Aaron's father had built underneath that field is a ground-coupled energy system. The formal engineering term is earth battery, though that name undersells what the technology actually does and how long it can do it. The principle it operates on has been understood since the 1800s. The application the Amish developed for residential use is more elegant, more durable, and more accessible than anything the modern energy industry will ever voluntarily tell you about. Because what it replaces is worth $400 billion a year in utility revenue, and every household that builds one removes itself from that revenue stream permanently. Let me give you the physics first, because the physics is what makes this impossible to dismiss. The ground beneath your feet is not electrically neutral. Soil contains dissolved minerals, primarily salts, and those dissolved minerals conduct electricity. When you introduce 2 different metals into that mineral-rich soil and connect them with a wire, a chemical reaction begins between the metals and the surrounding electrolyte. Electrons flow from one metal to the other through the connecting wire. That flow of electrons is electrical current. That is not a theory. That is basic electrochemical science taught in every introductory chemistry course in the world. The first person to document this effect systematically was a German scientist named Johann Wilhelm Ritter in 1800. He was working in the same intellectual environment that produced Alessandro Volta's first battery, and he understood almost immediately that the Earth itself could serve as the electrolyte in a naturally occurring electrical cell. But the most significant development came in 1841 when a man named Alexander Bain filed the first patent for a practical earth battery. Bain was a Scottish clockmaker and inventor, the same man who invented the electric clock and transmitted the first fax message in history. His earth battery used zinc and iron plates buried in moist soil and connected by wire. It produced enough continuous current to run his electric clocks without any external power source whatsoever. Bain's patent was followed by a wave of earth battery research across the second half of the 19th century. By the 1870s and 1880s, Farmers and telegraph operators across rural America were using ground-coupled cells to power telegraph lines across distances that centralized power systems could not yet reach. The United States Patent Office issued dozens of earth battery patents between 1840 and 1900. The technology was documented, tested, deployed at scale, and understood by working engineers and ordinary farmers alike. Then the commercial electric utility industry arrived, and the conversation stopped, not gradually, not as the result of some technical failure that made earth batteries obsolete. The conversation stopped because centralized electrical generation is worth an enormous amount of money to the people who control it, and a power source that any farmer can build from copper, zinc, and the ground under his feet is the direct economic enemy of every utility company ever incorporated. Thomas Edison understood this dynamic clearly. His entire business model depended on selling electricity generated at a central station to customers connected by wire. George Westinghouse built a competing model around alternating current transmission. Both men were selling the same thing: dependency. A customer who builds an earth battery in his back field is not a customer anymore. He is a competitor. The utility industry that emerged from the work of Edison and Westinghouse was never going to promote a technology that eliminated the need for utility service entirely. By 1910, earth battery research had effectively disappeared from American engineering literature. Not because the technology failed, because the technology succeeded in a way that made it economically threatening to the industry that was simultaneously consolidating its control over American residential energy. The Amish never got that memo. They were not reading the engineering journals that stopped covering earth batteries after 1900. They were not attending the industry conferences where the technology was quietly set aside. They were building farms and houses and workshops and dairies, and they needed power to run them. They evaluated what worked, built what lasted, and passed the knowledge from one generation to the next, without waiting for anyone's permission or approval. Aaron's father learned the basic principle from his own father, who had learned it from a community elder who had come from a settlement in Pennsylvania, where the technique had been in continuous use since the late 1800s. The knowledge chain was unbroken. While American engineering schools were graduating students who had never heard of earth batteries, Amish farmers in Ohio and Pennsylvania were maintaining systems their grandfathers had installed. What Aaron showed me that afternoon was a third-generation installation. His father had upgraded his grandfather's original system in the early 1970s, using modern materials, primarily copper and zinc electrode plates, rather than the hand-forged iron his grandfather had used. Aaron himself had serviced it once in 2014, replacing 2 electrode assemblies that had corroded beyond useful output and refreshing the mineral solution in the electrode chambers. The system had otherwise run without intervention since his father rebuilt it. 38 years of continuous electrical output from materials that cost less than $500 in today's prices, installed in 2 weekends, requiring 1 maintenance visit per decade. The average American household pays $1,400 per year in electricity costs, according to the U.S. Energy Information Administration. Over 30 years, that is $42,000 paid to a utility company. Aaron's family has paid exactly $0 in electricity costs during that same period. The system his father built has saved this single farm household the equivalent of a paid-off vehicle in utility costs, and it will keep saving that money for every generation that maintains it after Aaron. But the individual savings are not even the most important number here. There are approximately 80 million single-family homes in America. The electric utility sector collects roughly $400 billion in annual revenue from American consumers. A genuine national conversation about ground-coupled energy systems is a conversation about permanently redirecting a meaningful portion of that $400 billion back to the households it currently flows away from. The silence around this technology is not an accident of history. It is a financial decision that gets renewed every single year by an industry with every incentive to keep making it. Now let me tell you what a modern Earth battery system actually looks like. The version Aaron's father built in 1987 has been refined by a handful of engineers and independent researchers who kept working on this outside the mainstream. The core principle has not changed since Alexander Bain buried his zinc and iron plates in Scottish soil in 1841. What has changed is the electrode design, the collection circuitry, and the understanding of soil chemistry that allows a modern installation to produce dramatically more current from the same ground footprint. The fundamental components are these. You need electrode pairs, one plate of copper and one plate of zinc for each cell in your array. You need a mineral-rich soil environment, which most properties already have naturally, or which can be enhanced inexpensively with agricultural minerals available at any farm supply store. You need connecting wire between the electrode pairs and a collection bus that aggregates the output of multiple cells into a usable voltage. You need a charge controller to regulate the current flowing into your battery bank. And you need the battery bank itself, which stores the accumulated charge for use when demand exceeds the immediate system output. The Earth battery array does not produce high voltage. A single cell produces somewhere between 0.2 and 1.1 volts, depending on the metals used, the mineral content of the surrounding soil, and the moisture level. That is why you build an array rather than a single cell. 20 cells connected in series produce between 4 and 22 volts. 50 cells produce between 10 and 55 volts. The output is continuous, 24 hours a day, every day, regardless of weather and regardless of season, as long as the soil maintains adequate moisture and the electrodes remain chemically active. That continuous output is the characteristic that separates this technology from every weather-dependent, renewable system available today. Solar panels produce nothing at night and reduced output on overcast days. Wind turbines produce nothing when the air is still. An Earth battery array produces the same current at 3 in the morning in January that it produces at noon in July. The consistency is not a marginal advantage. It is a fundamental difference in how the technology integrates with the way a household actually uses power. Aaron walked me back to the barn as the afternoon light was dropping. The lights came on automatically when we stepped inside. The dairy cooling system hummed in the corner. His woodworking tools sat ready for the next morning's work. Nothing in that barn knew or cared that the grid was a mile and a half away. Nothing in that barn needed it to be any closer. The dirt underneath that pasture had been running this farm since before Aaron's children were born. It would still be running it after his grandchildren took over. The only question is why nobody told you it could do the same thing underneath yours. In 1873, a farmer in rural Indiana named Daniel Drawbaugh built an Earth battery array in his back field using copper and zinc plates he had cut himself from sheet metal purchased at a hardware store in Harrisburg. He connected 20 cells in series, ran wire through a buried conduit to his farmhouse, and used the accumulated current to power his experimental telephone receiver years before Alexander Graham Bell filed his famous patent. Drawbaugh was not a trained engineer. He was a farmer and a tinkerer who understood that the ground beneath his feet was already doing something electrical, and that the only thing missing was someone willing to connect a wire to it. When Bell's lawyers eventually challenged his telephone priority claim in court, 4 Supreme Court justices sided with Drawbaugh. The case was decided 5-4 against him. He died with almost nothing. The knowledge he demonstrated in that Indiana field, that ordinary soil in ordinary ground on an ordinary farm property, could power electrical devices continuously, without fuel, without wind, without sun, was documented in court records seen by thousands of people. And it disappeared anyway, not because it failed, because the men building the utility infrastructure of the 20th century needed it to disappear. The Rural Electrification Act of 1936 brought centralized grid power to American farms that had never had it. It was presented as progress, and in many ways it was genuinely useful. But it also arrived with an invisible price. Every farm that connected to the grid became a permanent customer. Every farm family that learned to depend on the utility switch on the wall forgot, within a single generation, that the field behind the barn had been producing electricity since before the grid existed. The Amish accepted none of that bargain. They evaluated the grid the way they evaluate every outside system, by asking what it costs in dependence, and they declined. The knowledge their communities had carried since the 1800s stayed alive in Holmes County and Lancaster County, and the settlements of Indiana and Wisconsin, while the rest of rural America plugged in and forgot. For a starter system that will power your essential lighting, phone charging, and low-draw electronics, you need 20 copper plates and 20 zinc plates cut to roughly 6 inches by 6 inches. Use copper flashing from any roofing supplier and zinc sheet metal from any metal supplier. Total materials cost under $150. Bury each copper zinc pair 18 inches deep in moist soil, spaced 3 feet apart in a line. Connect each pair in series with insulated copper wire. Run the collection wire to a basic charge controller rated for low voltage input, connected to a 12-volt battery bank. A 200 amp hour lithium battery bank costs under $200 today. That system, built in a single weekend, will charge your battery bank continuously, every hour of every day, regardless of weather, season, or time. It will not power your whole house immediately. It will power your lights, your devices, and your critical low-draw systems while you expand the array over time. Each additional row of 20 cells you add increases your daily output proportionally. Aaron's father started with 40 cells in 1987 and expanded to 200 over 3 years as he replaced utility dependence one circuit at a time. By the time he finished, the utility line running to the property boundary had not carried current in over a decade. The ground beneath your yard has been doing this since before Edison built his first generating station. The only thing that changed in the last 120 years is that someone convinced you to pay for what the earth was already offering for free. $150 in copper and zinc. One weekend. The dirt does the rest.